Hello, this is Suresh Upadhyay. As I've told you that I will cover loop entering or leaving a finite region of magnetic field in the next part. So let's start. This is our loop. Let we consider it's a loop which is entering in downward direction magnetic field. Here the magnetic flux increases because magnetic field increases. So and here uh, the loop which is leaving the surface which is leaving, so that's why the flux related to this loop decreases. So flux decreases because the number of magnetic field lines decreases. So that's all. So it is saying here the actual area of the loop does not change with time. However, the effective area of the loop through the magnetic field line pass varies with time. Same what I've said. Now Faraday's experiment. You know what have Faraday experimented? It is nothing but Faraday demonstrated the reverse effect of Oersted experiment. And what was Oersted's experiment? Oersted took a magnetic needle over a magnet and below a magnet, and he see the observations, and through the Oersted experiment, Michael Faraday did his experiment. He did the reverse of the Oersted experiment. Like what he did, he take a north-south magnet, and he take a galvanometer and two coil deflection. Then he see when the magnet is at rest, then the net deflection in the galvanometer is zero. This when he is taking the north pole towards the loop, then you see the galvanometer deflected towards the right, and the direction of current in the loop is opposite to the direction of galvanometer, opposite to the direction of galvanometer. And same here, when the magnet is going far, then it develops a south pole, and when the magnet is going towards, it develops a north pole. When it is going away, then it develops a south pole. And when magnet is moving away, our galvanometer show the deflection toward the north side. As I've told you that galvanometer shows the deflection towards the north side. As the north side is coming here, north side is going here, so galvanometer is deflected towards here, so it is deflected here. Like a north side of the magnet is going here, left side, so galvanometer needle will be going here, left side. So that's all. And the current in the loop is always opposite to the galvanometer. That is the point to be noted. Now this is also the same experiment. It is the same experiment. In this what he has done, he has changed the direction of the magnet. He is now take this side north, and taking this side to the loop, and observe the experiment. When he's taking the north to this loop, then the galvanometer needle, now this will be upright, this will be on the left side, this is on the left side. When this is at rest and this is in motion. When the south is when the south is going away from the loop, then the galvanometer deflection is towards right, means it is opposite from south. Okay. Now the deflection in the galvanometer is more when the magnet moves faster, less when the magnet moves slow. Obviously correct. When the increased strength of the magnet, the deflection increases. Absolutely right. When the increasing diameter of the coil, the deflection increases because the number of magnetic field lines increases. When number of turns of the coil increases, number of increase, that is the magnitude of current increases. Okay, done. Now magnet is stationary, coil is moving, so I think it's the same. Similar observation are obtained when magnet is kept stationary and the coil is moved. Okay, the same observations होती हैं ठीक है, like this is our coil and this is our magnet. Now magnet is at rest, our magnet is at rest, and this loop is going towards the magnet. So the galvanometer needle will be towards right. If it is going towards the magnet, towards the north pole, then galvanometer needle will be towards the north pole, and the current in this loop will be in opposite direction to the galvanometer, so it is clockwise. Here is it is anti-clockwise. Now see here, it is going away, so that's why the direction of the needle will be here. Okay, but this is anti-clockwise, so that's the direction in the loop is clockwise. Okay, now electromagnetic induction. It is a phenomenon of production of induced EMF on a coil when the magnetic flux linked with the coil is changed. Faraday first law: if there is a change in the magnetic flux linked with the coil, an induced EMF set up across the coil and remains till the magnetic flux change. If there is a coil and if magnetic flux linked with the coil is changed, it is saying if magnetic flux linked with the coil is changed, then the EMF is set up across the coil. Okay, actually it is, and remains till the magnetic flux change, and it will remain till the magnetic flux change. If the circuit is closed, induced current flow through it, and if the circuit is closed, okay. Faraday's second law: the magnitude of induced EMF is directly proportional to the negative rate change of magnetic flux through the circuit. This is what is a second law. Our second law is directly proportional to minus k change in phi upon t. E is directly proportional to minus k change in phi upon t. Now you should know only this: E is directly proportional to minus k change in phi upon t. We are doing competition, so that's why we focus on the competitive formulas, not on the whole theory or anything else. So there is a when just proportional signs, when जब हम हटाएंगे इससे तो कांस्टेंट आएगा, let the constant be k. So E experimentally E is minus के change in phi upon t हो जाता है, minus change in phi upon t. If the flux linked with the coil changes from phi 1 to phi 2, then E is minus phi 2 minus phi 1 upon t. Or if their coil is an n turns, if the coil has n turns, then this formula will be like E is equals to minus n change in phi upon t. Okay, minus n phi 2 minus phi 1 upon t. That's all. Now expression for induced current and induced charge. Okay, induced EMF, take it as potential. Let induced EMF, what is an induced EMF? What is an EMF? EMF जब मैग्नेटिक कॉइल जब कोई भी EMF, take it as potential, take it as potential, like this is potential, actually it is actually potential ही होता है, EMF potential ही होता है. तो E is minus n change in phi upon t. R be the resistance of the coil, let then the induced current, what is I is V upon R, वो होता है ना आपका फॉर्मूला, I is V upon R. Same here is used, I is E upon R, that is minus change in phi upon TR. Now induced charge, that is Q is IT. Now the induced EMF is independent of the resistance, that's our in this and specific resistance of the coil. मतलब जो induced EMF होता है वो independent होता है resistance से. induced EMF as it is seen, ये this induced EMF, इसमें कोई resistance तो आया नहीं है, that means induced EMF independent है resistance से and the specific resistance of the coil, and the coil can be made of any substance. कॉयल कैन बी मेड ऑफ एनी सब्सटेंस. इसका मतलब यही तो हो गया, अगर वो रेजिस्टेंस पे डिपेंड नहीं कर रहा तो फिर आप किसी भी तरह की कॉयल लगाओ, किसी भी तरह की इंड्यूस ईएमएफ में आप कोई भी तरह की कॉयल ले सकते हो. इंड्यूस ईएमएफ प्रोड्यूस होता है तो आप कोई भी तरह की कॉयल लो, देयर इज़ नो प्रॉब्लम, बिकॉज रेजिस्टेंस से इंडिपेंडेंट है. अलॉय ले लो, गो और किसी भी तरह की कॉयल ले सकते हो. ओके, इफ़ द कॉयल इज़ कट or is of an insulator, induced EMF will be produced, but आई इज़ जीरो बिकॉज रेजिस्टेंस इज इनफाइनाइट। अगर कॉइल को कट कर दिया कहीं से भी, जैसे मेरी पूरी होल कॉइल है, ये लेट एक होल कॉइल है, मैंने इसको कट कर दिया यहाँ से, आधी कर दी कॉइल, तो करंट इसमें प्रोड्यूस नहीं होगा, सर्किट ही क्लोज हो गया, सर्किट ही खत्म हो गया, कहाँ से करंट प्रोड्यूस होगा। अगर सर्किट खत्म हो गया, आई ज़ीरो हो गया, देन आई ज़ीरो है, रेजिस्टेंस क्या होगा, इनफाइनाइट हो गया, इनफाइनाइट तो रेजिस्टेंस इनफाइनाइट होगा। ये दो पॉइंट बहुत इंपॉर्टेंट पॉइंट, वेरी इंपॉर्टेंट पॉइंट। द इंड्यूस चार्ज इंडिपेंडेंट ऑफ द टाइम टेकन, बिल्कुल सी बात है, इंड्यूस चार्ज कहीं पे टाइम का रिलेशन है नहीं है। वैसे क्यूजिकल टू आई टी होता है, लेकिन हमने आई की जगह ये डाल दिया तो टी से टी कैंसिल हो गया था। सो इंड्यूस चार्ज टाइम से इंडिपेंडेंट है। वैसे हमेशा क्यूजिकल टू आई टी होता है, लेकिन फराडे के लॉ में जब हम इंड्यूस ईएमएफ और इंड्यूस करंट को पढ़ते हैं इनमें, तो इसमें ये टाइम से इंडिपेंडेंट है। बहुत बढ़िया बात, टाइम से इंडिपेंडेंट है, रेजिस्टेंस से इंडिपेंडेंट है। रेजिस्टेंस इनफाइनाइट हो जाएगा अगर करंट ज़ीरो हो जाएगा, या फिर कॉइल मतलब कॉइल को कट कर देंगे। तो ये दो तीन इंपॉर्टेंट पॉइंट थे। सो इन द नेक्स्ट वीडियो आई विल कवर द लैंड्स लॉ। Those who are watching, please subscribe my channel. Thank you.